Welcome back. In this video we're going to break down how to interpret data in IB Biology so that you can feel more confident and avoid common mistakes. Whether you're just starting out or revising for exams, these tips should help you build skills for your biology toolkit and tackle database questions in any subject more effectively. Here's what we'll cover. First, we're going to look at different ways in which biology data might be presented. Then we'll explore a few unusual ones that could catch you off guard from past papers. And finally, I'll be sharing 6 key strategies to help you avoid mistakes and get more marks. So first, here's a classic bar chart. Very common. The exam papers are all in black and white, and students tend to do very well on these. This is a stacked bar chart. Again, I don't find these a major problem for students. This is basically showing the proportion of the whole. For this bar chart, you can see that we've got error bars. Now, error bars are something that students don't always understand very well. They might not just be on a bar chart, they could be on something else. So they're showing the variability around the data. Here, for example, we can see that with squirrels only and on scented paper, that has more variability around the mean than any of the others. In this bar chart, you can see that these data points are quite close to each other, but M1 is higher. However, the error bars completely overlap, so that would suggest that's not a significant difference between the two. Scatter graphs are a common feature. They may or may not come with a trend line. You may be asked to describe any trend or if there is a correlation. Sometimes you might be given an R² value, otherwise known as the coefficient of determination. The higher that is closer to 1, that's going to mean a stronger correlation. So here we can see that as dietary fibre increases, total energy intake increases. This is a nice scatter graph again. As oxygen consumption increases, the total volume of air inhaled increases. There's a clear positive relationship between the two. Sometimes you're going to get data points for 2 sets of data plotted on the same axes. So these are good for compare questions. Just notice the command term on these. So if they ask you to compare the data, say for Bolivia and Australia, then you would be looking actually for a similarity. If they ask you for distinguish, you're looking for a difference. So for example, you can see that the trend line always has the saturation of hemoglobin in Australia lower than the Bolivian data. If they ask you to both compare and contrast, you're looking at giving a difference and a similarity. Look at the number of marks. If there's 3 marks, that might be 2 differences and 1 similarity that you're given, or vice versa. Here you've got 2 scatter graphs and you can compare the 2 sections, but do note that the axis here, the scale is the same. Sometimes that's not the case, so have a close look. Again, you can see this is showing a negative trend. This is showing a positive trend. But without an R², it's hard to see if that's significant. On this kind of graph, it's a scatter graph with a trend line, but we can see it's broken into 2 parts. So a common question for something like this might be describe with 2 marks available. So what we can see here is as the light intensity increases, the rate of photosynthesis increases, but that's only true up to about 600 units, arbitrary units. Once it goes beyond that, you've got no further increase in the rate of photosynthesis. Sometimes you may get a very simple table to analyse. Often you'll get a pie chart, and again I find students do very well on pie charts. This is becoming a more common feature. This is a box and whisker plot. For the new First Exams May 2025 papers, this is explicit within the syllabus. So they're expecting you to know this. They expect you to know that this line across the middle is the median value. They expect you to know that this is the interquartile range going from 25 to 75% of the data. And then you've got the minimum and the maximum, so you've got the full range here. Occasionally you may find a data point beyond that full range, and that's because it's been identified as an outlier, i.e. is more than 1.5 times the interquartile range. On this graph you can see they're not telling you that this is the median line, this is the interquartile range. So you're expected to know that. For these two graphs you have two sets of data, so I find it very helpful to actually colour one in with a highlighter. Not so difficult on this graph, but say the next one where you've got multiple lines, say you are being asked to compare the data for tuberculosis vaccine with the first dose of measles. It would be quite hard to see that unless you actually coloured it in. Sometimes you're given data based on familiar circumstances. So that's especially true for paper 1A, paper 1B. This question is about Vibrio fischeri, a bioluminescent bacterium as seen up here, and you can find that in the bobtail squid. When it's together, you get quorum sensing, so when there's a high population of the bacteria, then that induces them to bioluminesce, and that enables your squid to bioluminesce and actually hide its shadow. However, in paper 2, you'll find more unfamiliar context in that very first question. So expect the unexpected. The more you look at past papers and see different types of examples, the more of a chance you're going to have. Here's an unusual image, but it's quite straightforward if you read the information in the stem here. Again, an unfamiliar image, but actually quite straightforward to interpret. This is a question from a few years ago that really threw some of my students, is a violin plot. But don't be put off. They've given you a lot of information in the stem, so you can interpret these graphs no problem. It's telling you, oh, this is the median, here's 95% confidence limits, and it tells you that this is the upper and lower estimates. Now, one of the main things I find that students do wrong is not getting their ruler out for these database questions. It may seem very simple, but it's so important. So here's a question. Read the question carefully and then make sure you're looking at the axes and the key as well. So I suggest you bug the question. Put a box around the command term. It's estimate. It's not asking you to give a range or say about. You're going to give a straightforward answer. Underline the key terms. So here prevalence, which is what's on the y-axis. P enterotype, which is here on the graph. BMI of 50, so we're going up here. So your next job is to draw a line up from 50. Then this is actually a stacked line graph, so you're going to go to the highest point and go across, and then you're going to go to the lowest point and draw across. Then you can take your 0.65 reading off the scale minus your 0.30, you get an answer of 0.35. So let's just recap your exam strategies, okay? First of all, read the stem of the question, read the axes labels, read any key, and make sure to use those terms in your answer. If they haven't stated the units, you need to state them, otherwise you lose a mark. Bug the question, i.e. box the command term, underline the keywords, and once you've put your answer, go back and check you've answered the question correctly. The number of marks for a question is always important to guide you on how many points to make. Use a ruler to read off information from graphs accurately. They will give you a range, but it's a small range. Highlight or colour trend lines to make them easier to follow. And if you get stuck on a question, maybe because it's a kind of graph you've not seen before, just put an asterisk next to it, move on so you don't waste time, and come back to that question later. The best thing you can do is practice with past papers so you can build and embed these skills into your own biology toolkit. If you found this helpful, please do give the video a like and make sure you stay updated by hitting subscribe. I'm creating more videos or revision techniques and strategies just for IB Biology students is all designed to make you feel more confident. So please do share this with your fellow students. You've got this, keep practicing, stay calm and go smash those database questions.